All right, in a previous video, we looked at finding the 6 trigonometric functions values of an angle that's on the unit circle, right? We did one where t was 5 pi over 6, right? I didn't give you the unit circle then because I wanted to talk about reference angles, okay? Now, why am I putting this unit circle with this problem? In fact, it's kind of getting covered up a little bit, so let me pull it over here a little bit. Why am I giving you the unit circle now? Show me where 9 pi over 4 is on the unit circle, right? You can't because it's not labeled. It's there, it's just not labeled, right? So there are really a lot of different ways we can talk about this problem, okay? So to find the exact value, exact means no decimals, so throw the calculators out, right? This answer is going to be a fraction. It may or may not include a radical. It's probably going to be some ones, twos, or threes in there, right? Because a lot of these have ones, twos, and threes and radicals. So that's our guess. Now, when it comes to finding secant, okay, and this is how I approach these problems, take it or leave it. What I tell my students, and I have been telling them for over a decade, is when you're asked to do anything with secant, when you're asked to find secant, not every single time, but in a lot of these cases, the best approach is to find cosine first. Because if you go back and you look at some of these problems that we've done, right, when we were doing this problem previously, we found what cosine was and then we flipped it over, okay? We found what cosine was and then we flipped it over to get secant. So secant has its own interpretation of being 1 over the x coordinate, right? The secant of any angle is 1 over x. It's 1 over the cosine of theta. There's a bunch of different representations for what secant is. But again, in my opinion, the one size fits all, as best as we can get to that, the best way to think about secant is cosine flipped over. Okay, that's what secant is. And the more we focus on sine, cosine, and tangent, these reciprocal functions become a little bit simpler. So, do we know how to find the cosine of an angle on the unit circle? Yeah, that's just the x coordinate. And we have all these x coordinates, right? So that's the first thing. Anytime you're asked to do a reciprocal function, secant, cotangent, find its reciprocal first, sine, cosine, or tangent, then flip it over. That's just my professional advice to you. The second thing is, where's 9 pi over 4? Okay, we know for a fact that it has to be one of the pi over 4 angles. So let me get a different colored pen here. So it has to be one of these pi over 4s. These are the only angles that are labeled as pi over 4. And if an angle is given in terms of pi over 4, it has to be coterminal with one of them. All right. Now there's a couple of different ways you can do this. Like I said, you can take 9 pi over 4 off to the side and find its coterminal angle by adding or subtracting 2 pi, right? We're not going to add 2 pi because that's going to make it even bigger. We want something that's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So we can take 9 pi over 4 and subtract 2 pi, in this case, 8 pi over 4, like so, and determine that 9 pi over 4 is coterminal with pi over 4. That's why we spent all that time talking about coterminal angles. So the cosine of 9 pi over 4 is the exact same thing as the cosine of pi over 4. I don't have to worry about changing this into a different representation because they're coterminal. They are exactly the same, okay? And the cosine of pi over 4 is the x-coordinate at pi over 4, which is radical 2 over 2. So if the cosine of pi over 4 is radical 2 over 2, you ready for this? If the cosine of pi over 4 is radical 2 over 2, that means the cosine of 9 pi over 4 is radical 2 over 2, which means that the secant of 9 pi over 4 is 2 over radical 2, right? We flip that value over. And then we have to rationalize this, of course. We're not going to leave that radical in the denominator. So we have 2 radical 2 over radical 4, which is 2. The 2's cancel, and we're left with just this, okay? So it was a fraction, but when I rationalized it, it ended up being just radical 2, All right, so things to take away from this. Anytime you have a reciprocal function, deal with its reciprocal instead. Okay, secant, don't do secant, do cosine. Don't do cosecant, do sine. Don't do cotangent, do tangent. Okay, do all of your work there. Then when you're done, flip it over. If the angle that you're asked to use is not on the unit circle, find its coterminal angle by adding or subtracting 2 pi until you find the angle that's on the unit circle. Okay? And while we're here and I have your attention, let me give you just a different way of thinking about this. Okay? This won't take long. Here's one way that I've taught this in the past. Okay? Let's use red. We have red already. Every time we rotate 45 degrees, we rotate pi over 4 radians, right? So what I'm starting with here is an angle in standard position. If I rotate up to here, that's pi over 4. If I rotate another 45 degrees, what's that? That's a 2 pi over 4. But 2 pi over 4 reduces to pi over 2. So here's 2 pi over 4. Here's 3 pi over 4, right? 3 pi over 4. If I keep going, another 45 degrees, that's 4 pi over 4, which reduces to pi. If I keep going, 5 pi over 4. If I go again, another 45 degrees, that's 6 pi over 4, 7 pi over 4, 8 pi over 4 is 2 pi. You can keep going. If this is 8 pi over 4, this is 9 pi over 4. So you're basically counting the pi over 4 angles every 45 degrees, and not just the ones that are labeled that way, actually rotating 45 degrees. So you're having to stop at some of these pi over 2 angles. Okay? It's just a different way of using the unit circle, kind of like a clock face as you work around for some of these angles. So something else to keep in mind as you're working through some of this.